All right, so what we're going to talk about is the uniform distribution, one of three famous continuous distributions that are used. With the uniform distribution, we are defining a random variable between two values a and b. And what we are basically saying is that the chance of getting an interval of values of a specific length is the same no matter where you are in the interval. So let's just say, for example, that my interval of interest is between those two values. We're saying that the probability is the same on that interval as it would be on this interval here. And when we get to a specific example, we'll see more illustration of that. The uniform distribution is used when we don't really have a handle on what the actual probability distribution is. But what we do have is a specific lower and upper value that our random variable could take on. So we just assume that it's the same throughout the entire interval. That way we can at least have some kind of baseline estimate as to what's happening. So for an example, let's say that our random variable is uniformly distributed between a equals 6 and b equals, let's use 14. Okay, so that means that f of x, following our function up here, is 1 over, well, let's see. So that's 1 over, now 14 minus 6 is 8. So that means our rectangle, as depicted in the upper left-hand corner there, is 1/8 unit high. And that means it's 0 everywhere else. So if we're drawing this, so here's 6, here's 14. Let's say that this is 1/8 of a unit high right here. And what you can definitely tell is that that area is equal to 1. In fact, I'm not going to write that in there. I'm going to write it on the outside because we're going to answer some questions here. Okay, so the area is 8 times 1/8, which is 1. So what if I want the probability that our random variable x is between 7 and 9? Well, from what we know about finding probabilities is that it is the area under the curve. So here's x equals 7, and here's x equals 9. So the area of that rectangle is, it's 2 units wide times 1/8 units high. So that means the probability would be 1/4. Now let's pick another interval whose width is the same. Let's say I want the probability that x is between 10 and 12. Well, I'll use a different color here. If we use 10 and 12, that has the same length and the same height. So that means the area should be the same and is also 1/4. So one way to depict this probability is to say something to the effect of this. We can say the probability that a, well, I don't want to use a and b anymore. I'll want to say x1 and x2. So remember that this is just our random variable here, is the same as the length of the interval x1, x2, divided by b minus a, which is the length of the interval. We can also just say it's x2 minus x1 over b minus a. So that's a very simple probability problem to answer. Just take the length of the interval of interest, provided that it is in between a and b, and we go from there. So how about all the other peripherals about a probability distribution? As you can probably see, the mean, the average value, is going to be the value that is halfway in between the endpoints because it's an even slate all the way through. So the mean would be a plus b over 2. Turns out that that is also the median. So we could also say that mu is equal to a plus b over 2. We're talking about a population mean there. One thing we can also talk about is the variance, sigma squared. And that is, now we need calculus to officially derive it, so I'm just going to give you the result here. Sigma squared is b minus a squared divided by 12, which means that sigma is the square root, which would be b minus a over the square root of 12. So there is the peripherals and the ins and outs of the uniform distribution. I thank you for watching.